Okay, my people, we have two final problems here using Pythagoras. And at a first glance in these two problems, you're like, excuse, these are rectangles and squares. I don't see any triangles. But diagonals are these lines that we can draw in to kind of connect one vertex of a rectangle to another vertex. And when we draw these diagonals in, hopefully you recognize that we have a right triangle on over here, and also we have a congruent right triangle over here. And it doesn't really matter which one you kind of notice, we just have to use one of them to be able to solve for x in here. And that's the first goal, is to find x. And then the second goal is to find the perimeter of the rectangle. So let's get started in here. So we have a rectangle, and I notice I have some tick marks. So if that's 16, this one is also 16. And if that's x, this one is also x. So now I'm going to use the triangle on the bottom here to set up Pythagoras. Notice the length of the diagonal is 20, and so this is going to be what? X squared plus 16 squared equals 20 squared. So that's the new stuff. The new stuff is setting up an equation using Pythagoras, and now everything else is supposed to be old hat, meaning we're supposed to be able to solve for this without any errors. So 16 squared is 625, and 20 squared is 400. So when I bring the 256 on the other side, I think that's 144. And yes, it is. So that's 144, and so x equals the square root of 144, and that's 12. So if this side is 12, that means this side is 12. And so that's the answer to the first question, find x, and we just found x. The other question is find the perimeter. Well, the perimeter of this is the distance around the entire rectangle in here. So what is it? Well, it's 2 times 12 plus 2 times 16. And so if I take 2 times 12, that's 24. 2 times 16 is 32. The grand total is 56 units. I didn't say whether this is kilometers or inches or meters or miles or any units. So it would just be units. 56 units, that's the distance around that particular rectangle. Well, let's do our final problem in here, but this one is a little bit more than a rectangle. It's a square. What makes this a square is all of the sides are exactly the same here, and the only thing they told us is the diagonal of the square is 8 units long. So if this is y in here, that means this side has to be y, that side has to be y, so that side has to be y. So now this is not just any right triangle. We learned earlier that this has a very specific name, and this is the Isosceles right triangle. And so we can still use Pythagoras here. Notice y squared plus y squared equals 8 squared. And again, the reason why 8 squared is by itself is because that is the hypotenuse. That's the side that's opposite the 90-degree angle. So this turns into 2y squared equals 64. And if I keep on solving for this, dividing both sides by 2 gets me y squared to be 32. And so y would be the square root of 32. And if you take the square root of 32, it can be broken down into radical 16 and radical 2. So that equals what? This equals 4 radical 2. That means this side is 4 radical 2. That side's 4 radical 2. All these sides are 4 radical 2. And there's 4 of them. So how do I find the perimeter? Well, the perimeter here is I have 4 equal sides, and they're all length 4 radical 2. So when we multiply numbers and radicals together, this is going to be something that we learned in an earlier section of simplifying radicals. This just turns out to be 16 radical 2. And again, I didn't put any sort of units in here. This is just units, right? Units refer to miles or kilometers. And since I didn't state it, we just put a U there to represent that's units. So I didn't find the area here. I found the perimeter. The perimeter is the distance around the entire shape. And since I have 4 radical 2 and 4 radical 2, 4 radical 2 and 4 more radical 2, altogether I have 16 radical 2. All right. Good job, and let's start the homework and ask lots of questions on Pythagoras.